partial derivatives viewed as a rate of change and slopes. Okay, so last time class, we have here the partial derivatives being viewed as a rate of change and slope. Okay, so considering now class the figure here, which is the line being tangent to the surface. Okay, so this is our lesson for today. Okay, so we're going to apply partial derivative viewed as a rate of change and slope. And by definition, when we define the equation of this tangent line class, we have here in the x direction and in the y direction. When we are to find the slope of this tangent line in the x direction, it is defining the partial derivative of the function with respect to x. Okay? And the other one, if you're going to find the slope of this line in the y direction, it is also simply defining the partial derivative of the function with respect to y. And what are these two equations class? For the equation of tangent line, so we are to find the equation of the line in the x direction. So the formula for the tangent line now is z minus z sub 0 is equal to m times the quantity x minus x sub 0, where we have m sub 0 is the value of partial z with respect to x at a given point p. And of course, m sub 0 is the slope of tangent line in the x direction, where we have now the tangent plane is y equals y sub 0. Then the second equation of tangent line, wherein we have the slope of tangent line in the y direction. So we have z minus z sub 0 equals m sub 0 times the quantity y minus y sub 0, having tangent plane x equals x sub 0. Of course, again, m sub 0 will be now the value of partial z with respect to y at the given point p. Okay? So let us work on this example. Find equations of the tangent line or tangent to the parabola z equals x squared plus 3y squared, y equals 1 at the given point 2, 1, 7. Okay? So if you're going to verify from the given formula that we have, there are two formulas for the equation of tangent line. So which of these two formulas are we going to use? Is it the first equation or the second equation? So how can we define class which of these two equations can be used? So look at the given tangent plane class. It is y equals 1. Okay? So you check class the plane that is given y equals y sub 0. So therefore, it is equation 1 that we are going to use. Okay? And we are to find the equation of the tangent line in the x direction. Okay? So, we have now, again, let us have the function z equals x squared plus 3y squared, where we have the plane y equals 1 at the given point 2, 1, 7. Okay? So let us now define m sub o. So m sub o here is the partial z with respect to x. Okay, so differentiate now the given function with respect to x, where y is a constant. Okay? So get now the derivative of x squared. We have with us 2x. Then 3y squared, since it is constant, it is 0. Okay? So therefore, the slope is 2x. And then the value now of your m sub o, we just utilize class or use the value of the given point where x is 2. So we have now 2 times 2 equals 4. Okay? So what is then the equation class? So using now the formula, z minus z sub 0 equals m sub 0 times the quantity x minus x sub 0. And then we have the plane y equals 1. We will now substitute the point z sub 0, which is 7, then your m sub 0 is 4, multiplied by x minus x sub 0, which is 2. So defining now class, z minus 7 equals 4x minus 8. Or simplifying, we have z equals 4x minus 1. Okay? So at y equals 1, this is now then the equation of the tangent line. Okay? To the given surface. Next, we have the second problem. Find equations of the tangent to the circle x squared plus y squared plus z squared equals 14, where x equals 2 at the point 2, 3, 1. Okay, observe class that the equation is not in standard form. Okay, so what you're going to do, class, is to transform the given equation into standard form. X squared plus y squared plus z squared equals 14 is also now in terms of function f of x, y, z. You can say that we have this now as x squared plus y squared plus z squared minus 4. So we go now to tangent plane and normal line. Okay, so consider the surface defined by the equation f of x, y is equal to 0, and then let p sub o, we call this x sub 0, y sub 0, and z sub 0 be a point on the surface. So if we're going to look at the following figure now, class, we have our surface here, defined by z equals f of xy. Or it can also be f of xy is equal to 0. So observe the tangent plane here, class, or the plane which is tangent to the surface. So we call this as tangent plane at the given point. Okay? Which coordinates x sub 0, y sub 0, and z sub 0. So we call this plane the tangent plane to the given surface. What about now the normal line? The normal line is the line that is perpendicular to the tangent plane. Last time we have discussed normal vector. You still recall that? Okay, wherein we have a tangent plane and the relationship of the tangent plane to the normal vector, we have it as perpendicular. Okay? And the following formulas to be used for the equation of tangent plane and normal line, we have, for the equation of tangent plane, we have m sub 1 times the 1 x minus x sub 0 yung tangent plane. What about the equation of normal line? So we have the equation of normal line as x minus x sub 0 over m1 equals y minus y x sub 0 over m2 is equal to z minus x sub 0 over m. Okay? So it looks like familiar class because when we have our lesson last time of vectors, we see that it's similar to the equation of the plane, no? And then the other one is the equation of symmetric equation of normal line or symmetric equation of a line. Okay, so let us work on these examples. Find equation of the tangent plane and equations of normal line to the surface. X squared plus y squared plus z squared equals 49 at the given point 6, 2, 3. Okay, so let us work first on the example letter A. So again, let us write this in standard form. So where we have now f of x, y, z is equal to x squared plus y squared plus z squared minus 49. Then get now the partial derivative of the function f with respect to x. So where this is now our m1. So having now constants y and z. Okay? So this is the derivative which is now 2x. Okay? Then what is its value now? Use the given point 6, 2, 3. So we have now x is equal to 6. So therefore m1 equals 12. What about m2? For m2, we have to take the partial derivative of the function f with respect to y. Okay, go now to your equation. Then differentiate with respect to y. So x and z are constant. So for x squared, this is 0. And for y squared, this is 2y. Okay? What about the derivative of z squared? It is 0. And negative 40 is also 0. Okay? So partial derivative of f with respect to y is 2y. What about its value now plus 4m? So we will just have written now y is equal to 2 because y equals 2. So therefore m2 is 4. What about now m3? For m3 we have partial f with respect to z. Okay? Differentiate the function with respect to z now. So taking x and y as constant. So we have now the derivative of constant here is 0. Likewise, the second term is 0. What about the third term? So this is 2z. Okay? Minus 0. Then substitute now the value of z from taking from the given point which is 3. So 2 times 3 equals 6. So we can now define the equation of the tangent plane. Where we have the formula f1. m1 is 12. Then times x minus x sub 0. You get it from the given point which is 6. Then plus m2 which is 4 times y minus y sub 0 which is 2 from again the given point. Then we have lastly plus m3 is 6, then it is z minus 3, okay, equals 0. Then simplify now, we have 12x plus 4y plus 6z. Then we have the constant terms, negative 72 minus 8 is negative 80 minus 18. That will give you negative 19. Is this divisible class? You can reduce this by dividing the terms by 2. So that this is now, divide this by 2 plus. So we have now 6x plus 2y plus 3z minus 49 equals 0. So this is then the equation of the tangent plane. Okay? So you write now equation of tangent plane. What about now the equation of normal line? For the equation of the normal line, we will use the second formula, which is the second formula B. So using that now, you have x minus x sub 0, which is 6 all over m1 M1 is equal to 12 equals y minus y sub 0, which is 2 all over M2, which is 4, then equals z minus z sub 0, which is 3 all over 6. Okay, so this is then the equation of normal line. Okay, so insert yan in a box your final answer. Okay, the second function given. Still finding the equation of the tangent plane and equation of normal line to the surface. Okay, so we have now the second equation as you rewrite this as standard form. We have f of x, y, z is equal to, you have xy plus zx plus zy minus 26 as a given point, which is 6, 2, 3. Okay, so let us define first M1. For M1, it is partial f with respect to x. Okay, so what are our constants? We have y and z are constants. Okay, so for the first term, differentiate now with respect to x. Copy the constant, which is y, then differentiate x, which is equal to 1. Okay, what about zx? So we have zx, copy the constant term, which is z, then differentiate x with respect to x, which is again equal to 1. Then plus, what about zy? So since they are considered as constants, okay, the derivative will be 0. Then likewise for negative 26. Okay, so therefore, you rewrite now as, so y plus z. Okay, we have now maxima and minima of functions of two variables. So consider the figure shown here. So what can you see here, class? It is a mountain range, right, class? So let us imagine the graph of f of two variables to be a mountain range, just like in our figure. Then the mountain tops, which are the high points in their immediate vicinity, where we have this as the high points. So these are called relative maxima of f. And the valley bottoms, which are the low points, these are the low points in their immediate vicinity, are called relative minima of the given function. So just as geologists might be interested in finding the highest mountain and deepest valley in an entire mountain range, so you might be also interested in finding the largest and smallest values of the given function f(x,y) over the entire domain of f. These are called the absolute maximum and absolute minimum values of f. Okay? So we have here now, so for maxima and minima, it deals with finding the maximum and minimum values of functions of two or three variables. And these are the steps to be followed in finding the maximum or minimum values of a given function of two or three variables. First one is we have to find partial derivative z with respect to x and partial z with respect to y. So this is our first derivative class. Okay, the second one, equate each partial derivatives to 0 to solve for x and y values. Then find the critical point or points. Then after that, find the second partial derivatives. And then after that, determine if the critical point or points is the maximum and minimum from the equation t equals a times b minus b squared. Now if the t value here is greater than 0 and a is greater than 0, then f has a relative minimum at the given point, x of 0, y of 0. Then if t is greater than 0 and a is less than 0, then f has a relative maximum of the given point, x of 0 and y of 0. Then if t is less than 0, then f has a saddle point at x of 0, y of equal to 0, no conclusions can be shown. Okay, by the way, what are these A, B, and C? So the A class refers to the second partial derivative of the function with respect to x, while B refers to the second partial derivative of the function f with respect to y. Then, what about C? So this partial derivative, this is the partial derivative of f with respect to x, then with respect to y. Okay? Okay, so let us have some examples now, class. Examine or test the function for maxima and minima. So find the maximum or minimum value. So we have the function given as c is equal to x squared minus 3xy plus by squared minus 7x plus 12y plus 10. Okay, so let's start by defining now the partial derivatives. Okay, so c sub x. So we have y now as constant. So what's the derivative of x squared? It is 2x. Then what about negative 3xy? Drop in a constant term, it is negative 3y. Then the derivative of x is 1. Okay. What about by squared? It is 0. Then we have 7x is negative 0. So therefore, so it's now 0 equals 2x minus by minus 7. Let us call this equation A. Okay. Then define now the partial derivative of the function say with respect to y. So we go now to back to the original equation plus having now x as constant, so this is 0 minus what about the derivative of negative 3xy? It is negative 3x copy negative 3x and derivative of y with respect to y is 1. What about 3y squared? This is 6y, okay? What about negative 7x? It is 0. Then what about 12y? It is 12. Then plus 0. So simplify, we get negative 3x plus 6y plus 12. Okay? Then again, we're going to set things of y to 0. Then we have now 0 equals negative 3x plus 6y plus 12. Okay? So let us call this equation B. Okay? So we have followed class the first step. That is calculating the partial derivative. Okay? We go now to finding now the values of x and y. Okay? So let us work on the two equations A and B class. Okay, so what are you going to eliminate here? The solve for x or the solve for y? If you want, you can eliminate class y immediately, right class? And that is equation A multiplied by 2 and then equation B multiplied by 1. Okay, so what do we get here now class? 2 times 0 is 0 equals 4x minus 6y minus 14. While A class, we have equation B multiplied by 1. So this is 0 equals negative 3x plus 6y plus 12. Okay, so solving now class for variable x or x plus, we have 2. So what's the x? X equals negative 2. Then you will now substitute this class value of x equals negative 2 in any of the two equations A or B. But we will choose as the simpler equation. Of course, that is equation A. Okay, so that is now 0 equals 2 times negative 2 minus 3y minus 7. So it should be minus 2. Okay, so the result should be x equals 2. So that we have now 0 equals 2 times 2 is 4 minus 3y minus 7. So 4 minus 7 is negative 3. If I know class, then transpose it on the other side, that becomes now 3. Okay, so let's solve now for y. The value for y is equal to negative 1. So what will now be the point? The point will now be x equals 2 and then y equals negative 1. Okay, so this is the given point. So let us determine now class if this point is maximum or minimum point. So by getting the second derivative of the function with respect to x. So let us now get the derivative class of the given function with respect to x. This is our function a while ago, right class? So what do we have here now? So the derivative class of 2x minus 3y minus 7 was just in e. Okay? What about say y? We go to say y, then take the derivative, second derivative with respect to y now. So this is 0, so we have here 6y is 6. What about now say xy? For say xy, we have this as, go back to your first derivative So take note that this is now your A, and then B, and then C. So what is then plus your D? The formula for D is A times D minus D squared. Okay, so what is A? A is 2 times 6 minus negative D squared. So what is then the value of D? 2 times 6 is 12 minus 9, so we have 3. And 3 is greater than 0. So determine also your A. Is A greater than 0? Yes. So therefore, conclude now that the given function f has a relative minimum at the given point, which is 2, negative 1. Okay? You understand, class? So that is what we have for maxima and minima for this given function. Okay? So, maxima and minima. Okay, if we have given here function f of xy equals 6x squared minus 2x cubed plus 3y squared plus 6xy. So let us now define first the first derivative of the function with respect to x. So we have it as 12x minus 6x squared. 3y squared since y is constant, so this is 0. Then 6xy will come in the constant term 6y. Then the derivative of x is equal to 1. Okay? Then set now f of x equals 0. So this goes 0 equals 12x minus 6x squared plus 6y. Okay? Let us have the other partial derivative. We start with respect to y. So taking out the derivative of the given function with respect to x, or rather with respect to y now. Taking x as constant, so the first term derivative is 0 because x is constant. Then the second term is also a constant, so this derivative is 0. What about 3y squared? It is 6y. Then we have, for the last term, its derivative with respect to y, copy the constant term, which is 6x. The derivative of y is equal to 1. Okay, then again, set now partial derivative of f with respect to y is 0. And solving now for y, we can express y in terms of x here. So we can have this as 6y was negative 6x, or what is y now? Divide both sides by 6, we have negative x. Okay, so we have this as equation 1 a while ago. Then the other equation is equation 3. So let us now find values for these two variables by substituting equation 2 in 1. So what do we have here? So 0 equals 12x minus 6x squared plus 6 times negative x. So simplifying, we have this as 12x minus 6x will give us 6x then minus 6x squared. Okay, then factor out 6x. So this will now give you, okay, the second factor will be 1 minus x. Okay, then equate each factor to 0. Then solve now for x, so that is 0. The other function is 1 minus x equals 0. So x equals 1. Then solve now for y. We can substitute these two values of x in equation 2. Solve for y. So we have when x is 0, what is y? 0. When x equals 1, what is y? Negative 1. So as you can see, there are 2 points here, class. Now, point 1 has coordinates 0, 0. And point 2 has coordinates 1, negative 1. Okay? So these are your critical points. us determine if these 2 points will be maximum or minimum points. Okay? So by taking out the second derivative of the function with respect to x and the other one with respect to y, second derivative with respect to y. Okay, let us have first second order partial derivative of the function with respect to x. So we go to its first derivative. So what's the derivative of 12x? So that is 12. What about 6x squared? That will be 12x. Then you have 6y is 0 because y is the constant. Okay? Then we have for the second order partial derivative with respect to y. So differentiate 6y. So it's just simply 6. Then what about 6x? So since x is a constant, so the derivative is 0. Okay? Then let us also define the second partial derivative of the function with respect to y. Okay? So taking it from the first derivative of x. So this time no x is constant. So beginning with 12x, so that is 0. Then what about negative 6x squared? It's also 0 because we have the independent variables y now and x is constant. So then for 6y, it is 6. Okay? Let us call this as our A. Then this is our B. And then this is C. Okay? As a shortcut. Because we will now define the value of t from having now a times b minus c squared. This is our formula last time, no? Okay. So what is then a? A is, we're going to find the value of a. Okay, by assigning now x value. We have, there are 2 x values here. One is 0, the other is 1. So let's just prepare a table for us to define easier if the given points is a maximum or a minimum. Okay? So let us have this as A, which is fxx. Then your B is fyy, and then your C is fxy. Okay, and then the last column is B. Then let us have the given point. So this is 0, 0, this is 0.1. And then we have this as point, which is 1, negative 1. Okay, for A, it is 12 minus 12x. So assign 0. So what is the value of A? 12 minus 12 times 0. Value of A is 12. What about if you have when x equals 1, what is then A? 12 minus 12 is 0. Okay? What about for B? B is just simply 6. We don't have variables, so we don't substitute any values of x and y from the given points in B. So you just write here 6 and then 6. Okay? What about C? Again, we don't have variables present in fxy or c. So this will be now c to take the value 6 and 6. Okay? Then defining now d, this is the formula for d. So that we have 12 times 6, that is 72 minus 6 squared. What value do we have? That is greater than 0. Okay? What about for the point, second point 1, negative 1? So A is 0 times B is 6 minus 1 is 6 squared, and this gives us less than 0. So what is now your conclusion? Your conclusion is that we can say that P1 at P1 or at the given point 1 at 0, 0, we can say that F has a relative maximum or minimum? It is minimum. Because your A is greater than 0. Okay? What about at the second point? We sub 2, which is 1, negative 1. The value of B is less than 0. So that means F has a saddle point